they will also say that if a sniper is, is trying to hit something a great distance, a couple of miles away, they have to take into consideration the spinning of the Earth, because they say that as the bullet leaves the muzzle of the gun, it's now independent of the rotation of the Earth. So, the Earth will spin away from where the bullet, and you have to take that into account. They say that about artillery shells as well, but it's not true. If that was true, a sniper would have to spend ages and ages calculating how to make that shot, and they don't. They literally take into consideration the wind and the elevation, and they don't take the Coriolis effect into consideration at all. Also, planes. If that works for bullets, if bullets, as soon as they leave the Earth, they're now independent of the spin, then why doesn't it work for planes? Yeah. There's a video on YouTube that actually tries to explain that the Coriolis effect works by using the example of a paper plane. You have to throw it. If you throw it north, the Earth will spin and the plane will land sort of east. But if you take the idea of a real plane, a plane would have to aim north to go east in that case. But that's not what happens. And if that was the case as well, planes would have to land on runways that are moving, and that would be impossible. But how is it that you can take a flight from London to New York and it will take exactly the same time as a flight from New York to London? Yeah, one's with the spin of the planet and the other one's against it. So it doesn't make sense. They'll say that the whole atmosphere is moving, yeah, with the planet, but that doesn't make sense either, because the atmosphere, say it's that thick, the top layer of the atmosphere will be moving slow, and as further you get in, will be moving faster. So how, if everything is moving like that, how do you get a light breeze that blows against the spin of the planet? How do you get a breeze that goes from north to south? It just doesn't make sense. And again, science will give you calculations and esoteric ideas, but you can go out and look for yourself, and you'll see what makes sense and what doesn't. The other thing is that we have senses to be able to sense acceleration. You get in a car and somebody puts their foot down, and you get thrown back in your seat. You can feel the acceleration. Yeah, you can feel changes, very minute changes of acceleration. Yeah. So how is it that if you live up here in Macedonia, yeah, which is spinning at maybe 700 miles an hour, yeah, because the speed it's spinning is slower than this speed. So if you took a flight down to Africa, yeah, on the equator, why don't you feel the change in acceleration? Yeah, so why don't you feel the change in acceleration? You have these senses that will register the slightest change. Yeah, but you get off the plane there and you don't feel dizzy, because now you're moving a lot faster. So no, it doesn't make sense.